Hello, my name's James Hughes.
And I'm Ignacio Corderi.
We're here to talk about the Kinetic open storage system and how it is configured to use Swift. I want to start off with a primer of what is the Kinetic open storage system, and then Ignacio is going to finish with how Swift has evolved and is configured to provide high performance and low TCO. The Kinetic open storage system is designed to take an application that talks keys and values and actually give it a better service than the traditional systems. The traditional systems really use an application that talks a file service API through POSIX, through a storage server down to a device. With the Kinetic open storage systems, it's much easier. The application talks to libraries, the libraries talk across Ethernet directly to a device. The results is a much lower cost of ownership. We take a standard recording device, we take a key value API, and we have an Ethernet connectivity. It's the combination of those three items, which is the standard recording device, the key value interface, and the Ethernet connectivity, that makes this such a rich device. The Kinetic open storage device is a standard form factor. Instead of having two SAS ports, it has two Ethernet ports. Instead of having the SCSI command set, it has the Kinetic key value API, where every piece of information you want to store is a value up to a megabyte long, and it's described by a key up to 4 kilobytes long. And you basically say, put key value, just like you're doing a map inside of an application, or get the key, get the value associated with the key, or delete a key. And compared to a standard conventional disk drives, where they use SATA commands that really require you to read and write logical block addresses, now you have a device that can actually make requests and describe the data by a name instead of a number. You take these Kinetic devices, you can put them into systems. These systems are trays that have the first level of switching. This first level of switching then goes up to the top of the rack, and then you have all of these devices are directly addressable from the machines to the devices. A Kinetic device really has two different forms. One is a high-density hard disk drive, which has a very low dollars per gigabyte, low dollars per gigabyte per second for throughput. And there are many people, and we're working on a flash-based version of Kinetic that has a low cost of dollars per transactions. All of this communicates from the application directly to the drive, and also from drive to drive or drive to flash, so that it actually can move data between tiers. Today, when you have a storage systems, you typically have a front-end machine, you have a data center and a core machine, and then you go to a back-end machine, and then you go to a back-end tray. This is a traditional Swift configuration, where in this case the client would be a proxy, a Swift proxy. And then it goes across the data center core, and then it goes to an object server, and then to a tray of drives. That existing flow is well, it's the way it is. And if you look at just the storage servers, the object server itself, it typically has a tray with 60 or 70 or 90 disk drives, a couple of SAS switches, and that goes up to two servers. Those two servers go up to the top of the rack switch. And the Intel server is typically two sockets, typically 48 gigabytes of RAM, about 1,000 watts. Now with Kinetic, what we've done is we've taken the trays and we've replaced the SAS switches with Ethernet switches, and now all of these drives just talk to the top of the rack. It gives you high availability, and it eliminates the servers. 0 servers. So with Kinetic, the traffic flow is from the proxy across the data center routers straight to the Kinetic shelf. And in this way, there are no servers, and there's higher density, lower power, better total cost of ownership. And the performance metrics on these devices is about 50 megabytes per second for sequential write data, random write data, sequential read data. And for random read, we really recommend you use a flash device, because it's a normal traditional hard drive that has seeks. And if you wish, you can come to the demo tomorrow in the OpenStack Summit Demo Theater. So to take these drives and turn them into a system, you have to have a clustering mechanism that really focuses on the performance, the reliability, and the management of the storage. It needs to be compatible with some large-scale application like Swift, and provide centralized management. So what we've done is we've worked with the Kinetic drives, we worked with SwiftStack to create modifications to Swift to make Kinetic work. So I'll turn it over to Ignacio.
Thank you, Jim. So now I'm going to talk to you guys a little bit about Swift and how it is that we got from vanilla Swift into a Swift that can actually handle Kinetic. What you guys are seeing here is basically a traditional deployment of Swift where you have the proxy servers, you have the ring that basically decides where, based on the key, the data landed. Then basically the data goes from the proxy to the corresponding object server, which then actually stores that piece of data into a corresponding drive. The first approach with Kinetic was to actually modify the bottom layer of the object server to actually understand Kinetic and send that data down to the drives. But very quickly, we came to realize that we had data coming into the proxy, then the proxy generating n number of connections depending on your replication level to multiple object servers to then transfer the data again over the network to the Kinetic drives. This is because the way Swift actually talks between the proxy and the object server is actually through the network, through HTTP requests between those two services, even if they're running on the same box. So the next approach with Kinetic was actually taking and modifying the object service, or actually modifying the proxy service to understand that what he wanted to talk was actually running locally on the same box and bypass the entire HTTP and whiskey stack within Swift and actually get much better latency numbers and overall achieve a much higher throughput through the same server because we were actually lowering the CPU consumption on those servers. The other great benefit of doing this as well was that the MD5 calculations were done exclusively on the proxy server instead of 3 times on the same machine because of the replication factor. And this is just another drawing showing you guys that with Kinetic deployments, we can actually have a mix of machines doing Kinetic, which is in the case of the arrow number 1, and then other machines that have a mix between Kinetic drives and traditional drives. And this is all depending on how you configure your object ring. If you guys want to know and are interested in more information about Kinetic drives, on these slides you can find our developer portal, our GitHub page, and our support emails, and you feel free to get in contact with us. Thanks. Guys?